Hello everyone, welcome back to NeuralLead. In this video, we are going to generate a simple neural network model for the automation of car game control. So we will start by explaining you this model through schematic diagram. Then, after, we are going to apply these material and methods. So let's begin with the launching of NeuralLead Maker. So, here you can see two options. One is to create new project and other is to import an old project. For our case, we will select Create Project. A dialog box will appear. Here we have to write name of our project. That's how it will create NeuralLead Maker window for our project. Here, you can find option to add components and select whether you want to add neurons group or connections. But before creating our neural network, we will explain flow of our project. So here is the flow chart for car game automation model. Here we will have 8 neurons groups. First is input group, then first convolution, then first pull group, then second convolution and second pull group. After this you can find full, dropout and output groups. So here in input group, it will take the images as an input. Then in first convolutional group, each neuron will be connected to input image group through convolutional 2D connection with certain value of radius RF. Then first pull group is connected with pull connection, but with lesser radius RF. Then there, you can find second convolutional group connected to first pull group through convolutional 2D connection. Then, after this, there is second pull group connected to previous second conc group through pull connection. This whole bunch of neurons groups forms feature learning of images. And all these connections have ReLU as an activation function. After these convolution and pull combinations, there is full group that is connected through full connection with neurons of last pull group. Then, dropout group is also connected through full connection with full group, though there is slight explanation about it that dropout helps to differentiate one image to another image by hiding some part of image that is given by us in terms of percentages. Then, finally comes the output group that consists of 2 output values given by user. And in our case, we will record image data while playing some simple car game that has only 2 control keys, left and right, because it's moving forward by default. We just have to control turn signals. When both neurons' outputs are 0, means car going just straight. And if one of them is 1, then there is either case of left or right, as shown in table. So that is the schematic diagram for our understanding. Now we will build neural network on NeuralLead Maker. By clicking Add Component option, we can click on Group to create neurons groups. Here, you can see 2 types of neuron groups. One is generator, other is normal. Since input is collected in this group, so this will be generator. Number of neurons on X, Y, and Z axis depends on you. For our case, we are taking neurons equal to the pixel of image that we will record, that is 200 by 150 by 1. So, as soon I click Enter, it gives total number of neurons. Now I will close Auto Close option so that I don't need to open Add New Component option again and again. And here I click on Add button. It shows me group has been created successfully. Now what is our next group? That is first convolutional group, so we name it Conv1. Since it's collecting data from generator group, that's why it's normal type of group, and when you select normal, next, you have to select neuron model. For our case, we are using traditional second generation neural network. Next, you have to assign activation function. In our case, we are using convolutional connection with ReLU activation function. So, we will select ReLU function. Now, next is number of neurons providing to group. Right now, I am leaving it as it is. Fortunately, in NeuralLead Maker, we have option to get optimization process for our designed neural network, so we will do it later. Right now, continue with creating neurons groups by clicking Add, and is created successfully. Now next is first pull group. Group type is normal. Neuron model doesn't need to change. So is activation function. For assigning number of neurons, we will go for optimization later. Now, second convolutional group. Other things remain same. Just to click Add Group. Then it followed by Next Pool Group, so we name it as pool_2, and click on Add. Now starting with classification part, first group is full group, so creating it. Next one is dropout group. And the last one is output group. Here we will change activation function to sigmoid to converge the result. And also number of neurons we know, that is 2, because of left key and right key. As it is last group, we will open auto close toggle. And click on Add. Here an orphan group is created so that fake connections are created with it. So, click on Add Component and Connection. Here, first connection is between input images and first convolutional group. So, pre-group is input images, post-group is conv1. And connection mode is convolutional, so we will select conv2d. After this, we have to add learning rule by clicking its button. Then we need to enable backpropagation toggle and save it for rest of groups too. Here again, toggle off the auto close option so no need to open from add component option again and again. Next, to assign range weight to the connection. Now need to assign radius RF. Radius RF are specified from the point of view of a postsynaptic neuron looking back on all the presynaptic neurons it is connected to. In our case of convolutional network, we will go with 3x3 grid radius RF. And stride means to jump on next location of grid. So here we will assign 2x2x1 stride. Padding remains same. And click on Connect button to create our first connection. Now next connection is between first convolutional group and first pool group. So pre-group is conv_1 and post is pool_1. And since it's pooling structure of feature learning, we will select pool type of connection. To more narrow down the results, here we will assign radius RF lesser than previous connection. So, providing 2x2 grid of radius RF and leaving stride and padding as same as earlier and create second connection by clicking on Connect. Now, coming towards synapses between pool 1 and second convolutional group, connection is same as first, that is conv2d. Now other specifications remain same, just we will change radius RF again to 3x3. Click on Connect. Now second pooling synapse between pre-group conv2 and post-group pool 2. And similar to previous pooling, radius RF will be 2x2. Now next connection is between pool 2 and full group. And as we discussed earlier, it's full type of connection. As we click on full, other features went away. Here just we can see only range weight. Now creating this connection. Next is between full and dropout, with full connectivity. Then last is between drop put and output groups. That is again full type of connections. Now toggle on Auto Close option, so as we click on Connect, it will automatically close this connection window. So here are all groups with specified connections. Then, here you can see that number of neurons for all groups are same. So, as we discussed about an optimization option in NeuralLead Maker, we will go on Project Option and select Optimize. First, it will ask to set the simulation runtime to 1. Then, it will ask to allot full value to generate a group. Then, here is the thing that it will change the number of neurons according to our connection type. So previously, it was 200 by 150 by 1 for conv1 group, and now 99 by 74 by 1. Now optimization for pool underscore 1, then for conv underscore 2, and last for pool underscore 2. Here you can check number of neurons for all neurons groups. For full and dropout group. We have to assign manually because of the connection type that is full connectivity. Optimization didn't change it. So we will assign same number of neurons as pool 2 has. Now, if you remember our talk about dropout, that it helps to distinguish between different images by hiding some part. So in our case, we will go with hiding of 40% of part. So that will be 0.4 for 40%. Now this is our neural network. Now we have to record data while playing car game. That is, I found on Enjoy 4 Fun website. So to record data by NeuralLead Maker, we will go on DataSet Generator, next on Multiple Input Outputs, then New window will open. Here you need to drag it little, so that when you click on Add Sensor option, you can see Game window. When you clicked on Add Sensor, you can see many options in NeuralLead Maker to record the data from various sources. In our case, we need data to be recorded as screen images per seconds, so we will select Screen. So again, a dialog box will appear. We need to adjust it little. Here, you can change the resolution of your screen recorder. In our case, we will assign 200 by 150 as we assigned number of neurons to our input group. Then, select area that you want to record. Red mask will help you to select area. And you can adjust it either by dragging whole mask area or by clicking on its borders. Once you adjust the mask, right-click and select Done. Now, our next senior is keyboard, so that when images are being recorded when playing a car game, it also record an action output from left key and right key to turn left or right. Once you added all sensors, you can change frames per second settings from options. In our case, we are going with 15 frames per second. And now, close the option window. Now adjust DataSet Generator window wherever you feel easy and click on Start Capture and click on Yes. Now screen capturing has started, you can play. Once playing game is completed, click on Stop Capture and click on Yes so as to convert recorded data into columns. Now here, you can see, as we discussed in Starter Video, that there are two outputs. If it is 1 and 0, then it means left turn, and if it is 0 and 1, then it's right turn signal. If both are 0s, then it's moving just straight. Now click on Export Data and save dataset in your project location so that you can find easily. Now repeat the process for validation dataset. This time click on No, so that your old dataset should be saved too. Once game is finished, stop the capturing and click on Yes to save data as column. Now click on Export to save that CSV file in same folder as you did previously. Write name for this file as validation. Now once data is saved, go to Data option in NeuralLead Maker and select images for data type for our input image group and numbers for output group. Now in Data menu, go to Import, click on it. Click Yes to import data into training dataset. Now select first dataset file that has modification date earlier. Click on OK to assign images to input group. Now click on Output, then again click on Import, and select Yes to import data in training dataset. Select first CSV format file without the name of validation. Further click Yes, then on OK, then again OK. It asks, is this data for input? Click No, then click OK to import CSV data in output group. Here you can see input and output data are synchronized. Now repeat same importing data for validation. Click on Import. Click Yes to import data into training dataset. Now select second dataset file that has modification date later. Click on OK to assign images to input group. Now click on Output, then again click on Import, and select Yes to import data in training dataset. Select second CSV format file with the name of validation. Further click Yes, then on OK, then again OK. Then it asks, is this data for input? Click No, then click OK to import CSV data in output group. Here you can see input and output data are synchronized. Now before running simulation, you need to select monitors, and then click on Run, then OK. And toggle of the Save as New Best Score option, and save it. Here it asks you if you want to disable UI option so that you can gain higher performance of simulation. So if you select Yes, you just see empty graphs and just status of simulation. But if you select No, you will see running graphs on monitor. For this cycle, we will go with No. Then here is another interesting part of NeuralLead Maker. That it allow you to run simulation on another computer via networking, or you can run on Cloud Accelerator that you can find on NeuralLead website, and also on your own computer. So, for sake of simplicity, we are going with the option of this PC. You can see its building project. It takes some time, depends on your connection speed. As you can see here, simulation has started, and here you can see error loss, current score, last score, best score, and status of training as good or weak. Our neural network simulation is taking images one by one as an input. Since we have selected No to disable UI option, that's why it's processing little slow. As we click on Disable UI option, it will go faster. Now here you can see it has reached more than 90%. Last score, best score, and below, new best score is updated in log. The right way is that we have to keep on the simulation till it reach 100%. But now, for the sake of tutorial video completion, we are stopping here. Once the training is finished, we can also test our neural network with a feature of testing data in NeuralLead. To do this, click on Test Data in Control Bar. Here, click on Reload I/O Structure. Now click anywhere inside Black Area under Input Group Name. Now select Random Image from folder where you saved DataSet. After selecting an image, click on Run button. Here, you can see output according to training that we have provided to our neural network. Now you can try it with few more inputs to test the training of your neural network. So that's how you can build neural network for simple car game automation by using NeuralLead Maker. Thank you, and have a nice day.